Hello everyone, my name is Rahul Yadav and today I will be presenting my MTech end semester assignment titled Lightweight Object Detection for Drones Under Motion Blur. This topic is particularly important for UAVs and high mobility platforms where images often get blurred due to rapid movement. So let's get started. Drones and UAVs have often captured images while moving at high speeds. Because of this rapid motion and vibrations caused in the drone, or maybe due to the object movement that it is tracking, motion blur occurs. This blur reduces the important details in the image, like the edges or textures and shapes. As a result, object detectors may produce missed detections or false positives and reduced accuracy under real-world UAV conditions. These problems becomes even worse because the standard data sets rarely include motion blurred samples. So the detectors which are trained on the clear images fails when deployed on the UAVs. Recent research identifies the need for lightweight solutions, real-time inference, and blur robustness for edge devices like drones. There are several techniques that are explored in the literature, which includes feature level deblurring using knowledge distillation, dual stream architectures combining restoration and detection, and optical flow based temporal fusions. All of these inspire our final proposed approach. So, moving on to the introduction section, the motion blur primarily destroys the high frequency details that are present, which are like the edges and the fine structures present in the video frames or the image frames. And in drones, this happens constantly due to the camera shake and fast movements. The traditional approaches like pre-processing, deblurring GANs, or heavy usage of CNNs are too slow and computationally expensive for the UAVs. So the goal of modern research is to directly integrate blur handling inside the detector instead of running a separate heavy deblurring module. Okay. Now, moving on to the objectives of our work, we need to improve the detection accuracy on blurred UAV images while keeping the accuracy high on sharp images also, and ensuring real-time performance suitable for edge devices. Also, we want to maintain a lightweight model without major increase in the parameters. Uh, and we want our model to efficiently handle different types of blur, which can arise due to camera shake or directional blur or the object motion blur. Okay. Now, scope of work. Scope of our work or the scope of this assignment includes studying how motion blur is formed and how synthetic blur is generated for training. And we want to analyze blur robust architectures such as the student teacher knowledge distillation frameworks or the dual stream restoration uh, and detection networks, and finally the optical flow guided temporal frameworks for the video blur. Now let's look at the detailed methodology. So first we'll be seeing at blur synthesis and knowledge distillation. In blur synthesis and knowledge distillation, we simply use a student teacher framework. The teacher receives a sharp image and the student network receives a corresponding blurred image. So I'll show you so the teacher will be receiving a sharp image, the student receives a corresponding blurred image, and these both networks share all the parameters except the deblurring branch, which is common or which is unique to the student network. Now the student learns the blur agnostic features using the high quality feature hints and the soft labels like bounding boxes and category probabilities that are provided by the teacher network. This enables the student detector to mimic the sharp image feature space even when it receives a blurred inputs. Okay. Now moving on to our dual stream restoration and detection. So the DREB-NET contains a blurry image restoration auxiliary branch, a multi-level guided feature fusion module, and a learnable um, frequency amplitude modulation module. Now the BRAB branch is like a UNet. I'll show you the image. Okay. So the BRAB branch is like a UNet module that performs shallow restoration of blur during training. The multi-level attention guided feature is a module which merges the restored features with detection features using local attention and global attention. This specifically boosts the small object detections under the blur, which is usually not possible with the traditional approaches. Now, the learnable frequency amplitude modulation module improves the high frequency details by adjusting feature amplitudes in the frequency domain. Eventually, or essentially, what it does is it strengthens the edge degraded due to motion blur. Now, together, these modules provide a strong robustness while keeping the inference lightweight. Now, also, one more thing to point out here is that in the inference engine, what we will do is in our final inference engine, we remove the BRAB branch and the teacher network. So our final inference engine only has the multi-level attention guided feature fusion and the learnable frequency amplitude modulation module, and which is a part of the student network. Okay, so moving on. So the restore is yeah. So that thing I told. Now finally the stream flow. Let's talk about the stream flow. To handle the video motion blur and temporal consistency, we add a optical flow based prediction using stream flow, and the optical flow uh, captures how pixels move across the frames, and the flow guided dynamic prediction module gives us a temporal cues. So we replace the base inference engine inside the FGTP module with our Lightwave student module, and this enables the final system to handle both frame level blur and motion over time, improving the UAV's detection under severe movement. Okay. Now, what we are expecting, or the what are the expected outcomes or the deliverables from this project are uh, we want a compact blur robust detection engine which is suitable for deployment on the drones, and we want the real time inference with a sub 10 millisecond latency, or uh, which is ideal for the high speed UAV operations, which generally works on 120 hertz refresh rate cameras. Okay, now what are the hardware requirements for this? So we basically will be requiring a UAV platform with a high-speed camera, and NVIDIA Jetson edge computing platform for implementing our inference engine, and a GPU-based training server where we will be doing all the training of our models, and finally some other testing and development equipment that will be required. Now, all the concepts mentioned and methods described here are based strictly on the research papers listed in the reference section of the proposal, including the work on DREB-NET or the knowledge distillation and stream flow. So I'll be attaching that in the comment section. So please go through that. And that is all. Thank you for watching my presentation on lightweight object detection under motion blur. And this concludes my NSEM assignment explanation. If you have any questions, I would be happy to answer them in the comment section or in person. Thank you.